For these first few examples here, we got multiplying and dividing, and we'll just keep the answers as mixed numbers if we need to, so no improper fractions on this one. But when we do these, we are going to be changing the mixed numbers to improper fractions in order to solve some of these. So let's take a look at number 1 first. So right here we need to change this 1 and 1/2 into a improper fraction. So 1 times 2 plus the 1 would give us 3/2 right there. Now when multiplying these, here we know that the answer is going to be negative because of the negative out here in the front. And from here we're just going to multiply the numerators and denominators separately. Some of you would do simplification at this point. Either way will work, whether we simplify now or later. So 4 times 3 is 12, and 16 times 2 is 32. Now we may notice that these two numbers, the numerator and denominator, are both even. So we could divide by 2, but if we look a little further, we can see that both of these are divisible by 4. So this ends up being a negative. 12 divided by 4 is 3. 32 divided by 4 is 8. And that would be our answer for this one. On number 2 here, we have 2 negatives. So we know the answer is going to be positive, meaning we really get to ignore these negatives right here. It wouldn't matter if we were multiplying 2 positives or 2 negatives. So to multiply these, we are going to change them into improper fractions. So we'll multiply and then add. 1 times 3 is 3, plus 2 is 5. We'll keep the denominator. And then 2 times 2 is 4, plus 1 is also 5, so 5/2. Now, one mistake we often see is that some people want to make these common denominators, which isn't a problem as long as you're not adding or subtracting. The problem with it is that at the end you'll have to simplify anyways. So if we look at this, expanding these or scaling them up is only going to make this a little bit more complicated. So just remember, when multiplying fractions, multiply straight across with numerators and denominators. 5 times 5 is 25. 3 times 2 is 6. Now, we don't want to keep this one an improper fraction, right, by the instructions. So we can use long division in order to figure out what this would be as a mixed number. 25 divided by 6. 6 goes into 25 4 times. 4 times 6 is 24, so we'll subtract that out. We got 1 remaining. So this ends up being 4 whole units, and then we have 1 out of 6 parts remaining. And this would be our mixed number. Now let's look at this fraction division stuff. So again, we're going to change these into improper fractions. 1 times 9 is 9, plus 2 gives us 11/9, and this is divided by negative 1 times 2. We can ignore the negative and just change this knowing that it's going to be a negative. 1 times 2 is 2, plus 1 is 3, so we have 3/2. Now hopefully you guys remember, we don't usually divide fractions, we usually multiply them. And to do that, we're going to change the divisor here into its reciprocal. So that would be negative 2/3 now. And then everything else from here proceeds as usual. 11 times 2 is 22 over 9 times 3 is 27. Now here's what usually happens with this is we forget this negative right here. Okay, and on a test it's okay, I can give you a lot of points for 22/27, but if we just remember to put that negative on there, you'll get full points. So just don't forget, if we have 1 negative, the answer will be negative. If there's 2, then it's going to be positive. So make sure you pay attention to that. If at the beginning you already knew that it was going to be negative from up here, then just write a negative with wherever you're going to write your answer, okay? Or circle it. Just do something so that you don't forget that negative there. All right, number 8. Again, changing these into improper fractions. Now, like I was talking about the negatives though, here I've got these 2 negatives, so 2 negatives is going to give me a positive answer. I don't even have to worry about those. Let's go ahead and just start by changing these into improper fractions then. 3 times 3 is 9 plus 1, 10. 10 thirds divided by, well, this is just going to be 5 sixths. Now I'm going to do this one a little bit differently, because after we change this to multiplication right here and reciprocate the divisor, 6 fifths, then we get 10 thirds times 6 fifths. Well, we can simplify the 10 with the 5 and make this a 2 and a 1. And we can simplify the 6 and the 3, making this a 2 and a 1. And now when we multiply, 2 times 2 is 4. 1 times 1 is 1, which really just is 4, okay? So I simplified that before I did the multiplication using cross simplification, which is possible, and there are many examples for you to see like that. For 9 and 10, we have to remember that the area of a triangle is 1/2 times the base times the height. Now the base and the height are always created by a 90-degree angle with one of the other lines. So if we see a triangle like this, we may see a dotted line like that with the right angle. These ones aren't showing that right angle, but that dashed line is showing the height of the triangle, right? We'll say that it's this tall height. Now on the other hand, sometimes we may just have a right triangle like this, and now the height is just this side length. But we may see some where they give us something kind of weird like this, and instead of giving us this line right here, what they'll do is they'll give us this line right here, which means that we have to know this side length. This now is the base. This is the height. Let's take a look at our equation again. The area of a triangle is 1/2 times the base times the height. And right here we can see that the base is going to be this line because it's 90 degrees with this line right here. So I'm going to replace the base with that 5 centimeters. And I'll replace the height with that 6 centimeters. And from here I'm just multiplying. Now, this is all, really it's just fraction multiplication. So I got 1 times 5, which is 5 times 6 is 30. 2 times 1 times 1 is 2. So the area of this triangle is 30 divided by 2. And the area of the triangle is now 15. But we can't forget to label this, okay? This is 15 centimeters squared. Some people prefer to write it as 15 square centimeters because area is now two-dimensional. So we have this area of this triangle, which is going to be in squares. So this is where it becomes important to remember the base and the height. So we need to look for the height of this thing, which is given to us using this line. Now, since I'm going to be multiplying, I'm going to change this into an improper fraction. 2 times 4 is 8 plus 3 is 11. So this is 11/4 in inches. And then my base as well is also a mixed number. I want an improper fraction here. 4 times 2 plus 1 is 9/2 inches. And I'll replace the base and the height respectively there. Alright, well this is all fraction multiplication. So the area of this triangle, 1 times 9 is 9, times 11 is 99. 2 times 2 is 4, times 4 is 16. So when we divide 99 by 16, we'll change this into a mixed number, which is good usually for measuring lengths like this or areas. So 99 divided by 16, that gives us 6. And after I subtract that 96, I get 3 remaining. So the area of this triangle ends up being 6 and a 3/16 square inches. Of course, if you wrote that as inches squared, that's not going to be a problem. Now here we got a rectangle, which isn't too bad because the area of a rectangle, this one's pretty commonly known as length times width. And for us, it's not going to matter which one we choose as length or width. So we can say that this is the length. 7 times 2 is 14 plus 1. This is 15 halves feet. So I'll replace the length with 15 halves. And then the width, 8 times 4 is 32 plus 1, 33. 33 fourths feet, and I'll replace that with the width. Now to me it doesn't look like either of these can be simplified, but 15 times 33 is 495, and 2 times 4 is 8. Now since this is an area, and yes, this would be in square feet, let's go ahead and change this into a mixed number. So I got 495 divided by 8. 8 will go into 49, let's see, 6 times. So minus the 48 gives us a remainder of 15 there, and 8 will go into 15 once, and that leaves us with 7. So this will be 61 and 7/8 square feet, or feet squared, and that would be my answer right there. Let's take a look at number 12. The recipe calls for 3 1/4 cups of flour. How many cups will you need if you are preparing 6 batches of the recipe? So it's 3 1/4 cups of flour, but since we're making 6 batches of this, we can just multiply this by 6. So once again, we want to change that 3 1/4 into an improper fraction. 3 times 4 is 12, plus 1 is 13, so this is 13 fourths times 6. We can make it 6 over 1, and yes, we could cross simplify here. Dividing both these by 2 gives us 3 halves, and when we multiply these, 3 times 13 is 39, 1 times 2 is 2. So we'll just change this into a mixed number, so it will show us how many cups we need. It appears that that will be 19 1/2 cups. And what about 13? If you only have 1/4 cup measuring cup, and a recipe calls for 6 1/4 cups of flour, how many 1/4 cups would you need to use? So we're going to take our 6 1/4, and we'll divide it by, that's a fourth, sorry. We'll divide it by the 1/4 of a cup. That will tell us how many 1/4 cups we need. But again, we'll change the 6 1/4 into an improper fraction. 6 times 4 is 24 plus 1. That's 25 fourths. And yes, we will change this to multiplication. And then we'll take the reciprocal of 1/4, which is 4 over 1. So we can see the 4's will cancel out. This leaves us with 25 over 1, which would just be 25. So how many 1/4 cups? 25, 1/4. We can separate these with of. 25 of 1/4 cups. In reality, we're just looking for the 25 though.